Hello students! Today we're going to talk about transformations on linear and absolute value functions. Now, we discussed this a little bit in the last lesson, but the first transformation that we have is called a translation. If you remember from our last lesson, translation means you take the entire function and you move it either up, down, left, or right. So we have a horizontal translation and a vertical translation. So if we start with a basic function f of x, in order to do a vertical translation, we would take the function itself and we would add some value to it. If we wanted to do a horizontal translation, we would take the function and we would subtract a value just from the input. So as an example, if we had the function f of x is equal to the absolute value of x plus 5. Now, if you look at that, you see that this already has a vertical translation applied to it. But if we wanted to take f of x and create another function that was transformed, let's say that we wanted to do another function that was translated 3 units down. So in order to translate 3 units down, I'm going to add a value to the output of the function. So the output would be this entire right side of the equation. So to translate 3 units down, we would have absolute value of x plus 5, that's the original function. But then we would add -3 to the outside, or we could do -3. So I'd have a new function g of x is equal to the absolute value of x plus 5 minus 3, or to simplify that, the absolute value of x plus 2. G of x would equal the absolute value of x plus 2. Now what if we wanted to do translated 3 units left? That's a horizontal translation, so in order to do that, we need to add a value just to the input. So the input is right here, so I would have my new function g of x is equal to the absolute value of x, and then to go 3 units left, I would do plus 3. Remember, horizontal transformations always do the opposite of what you would think. Left seems like it should be -3, but in this case it's actually plus 3. We've got the plus 5 on the outside right there, and this one actually can't be simplified, so we're done. The next transformation that we have is reflections. Now, reflections are one of the easier ones because we just multiply by -1, but the trick is, where do we multiply by -1? So, for a vertical reflection, a vertical reflection would be reflecting across the x-axis. To get a vertical reflection, I'm going to take the function and I'm going to multiply the output of the function by -1. But for a horizontal, that would be a reflection across the y-axis. I would take the function and I would multiply just the input by -1. So let's go ahead and take another example function. Let's say that we have a quadratic function this time. Let's do x plus 5 squared plus 2. So for a vertical reflection, that would be reflect across the x-axis. I would take x plus 5 squared plus 2. I would put that in parentheses and multiply the whole thing by -1. Using the distributive property here, I would get negative x plus 5 squared minus 2. We'll call that g of x. And be careful here, make sure you don't distribute the negative into the parentheses. Since that monomial has been squared, we can't multiply that negative in. So this would actually be the simplest function that we can get. If I want to reflect across the y-axis, I would just multiply the input this time. So that means that I would have x plus 5 squared plus 2, and then the input is just the x, so that means just the x is getting multiplied this time. That would give me negative times x is just negative x. The plus 5 stays. Squared plus 2. We'll call that g of x right there. That's as simple as that one can get. We'll move on. The third type of transformation that we have here is stretches. These ones are the ones that people struggle with the most. So for a vertical stretch, we're going to take our function f of x and we will multiply it times some number. So if I wanted a vertical stretch by a factor of a, I would multiply it by, just multiply the whole thing by a, multiply the output by a. But if I want a horizontal stretch, that means I'm going to have f of x, and then right here, I'm going to multiply by another value. I'm going to multiply it by b. Now, this one's a little bit tricky because just like the translation earlier, it does the opposite of what you would think. So, if I multiplied for a vertical stretch by a, it would be vertically stretched by a factor of a. But if I multiply horizontally, if I multiply the input by b, it will stretch or shrink by the reciprocal of this. So this will stretch, let's say horizontally stretch by a factor of 1 over b, the reciprocal of whatever that number is right there. Okay, let's try that with an example. Let's say that we have this function f of x is equal to absolute value of x plus 3 plus 2. Now, if I want to vertical stretch by a factor of 5, that means that I'm going to take the output, which is this whole piece right here, and I'm going to multiply the whole thing by 5. So that would be 5 times x plus 3 plus 2. And then using the distributive property, I would get 5 absolute value of x plus 3 plus 10. Remember, I can't distribute into the absolute value, so that would be as simple as I could make it. Now, if I wanted to do a horizontal stretch, by a factor of 2, That means that I now need to multiply just the input. The input is the x right there. So I'm going to have absolute value of x plus 3 plus 2. Except now I'm going to multiply right here where the input is. And the biggest trick here is I'm not going to multiply this one by 2. I need to multiply by the reciprocal of 2. So thinking of 2 as a fraction, 2 over 1, the reciprocal of that would be 1 over 2. So the answer to this one would be g of x is equal to the absolute value of 1/2 x plus 3 plus 2.